So here's a small example of how to conduct heteroscedasticity robust inference. And this is a data set that's coming from the Woolrich package, and it's called Apple. It's nothing to do with the company Apple, but actually the apples we eat. So the study basically was trying to collect experimental data because, or it's kind of close to a true experiment, because what they did in the study was ask the family head how many apples would they buy by presenting them with the prices of two types of apples. One was a regular apple, and the other one was an eco-labeled apple, maybe some fancy kind. Okay, and so the recording for each family by asking the head what the quantity in pounds would be, right, of each that they would buy. Now, they obviously collected other sorts of information about the family. So you have lots of variables here that tell you about, let's say, the family income. It tells you about the age of the head, and then it tells you about the number of people who are below the age of 5 or between 5 and 17, and so on and so forth. So, right, so if we were to think about doing some sort of regression analysis, we can say that, well, the quantity demanded of apples, and let's say we are talking about these eco-labeled apples, would depend on the price of the eco-labeled apples, plus the price of the regular apples, plus all these other demographic characteristics, right, that we have in our data set. So this is exactly what the regression is doing here, and we can call this regression reg apple, and we can take the quantity demanded in pounds for the eco-labeled apple and regress it on its price and on the price of the substitute, right, which is the regularly priced apples, and then the log of family income and all these other variables. Okay, and so we're doing exactly what we did in the previous video. We're basically going to use Stargazer to construct two columns. One column is going to be about the regular OLS output, and the other is going to be about the robust. So this is doing the robust inference on our regression, right? So we're using coef test. This is obviously assuming that you've already installed these packages here, Woolrich, Stargazer, and LM test. So you can go ahead and do this, right? So you can only use coef test after you've installed LM test. Okay, so coef test, and you're gonna state the name of the regression, the OLS regression, and then you're gonna say use modify the variance covariance matrix. Okay, so this is what we get. We get the second column. This is giving us a robust inference, and you can already notice that there are some things that are changing. For example, the level of significance of log of family income. So notice that in our robust inference, this is way more significant than what it was here. And sometimes you might even find that the either significance goes away completely, or some things become significant when they weren't significant under regular OLS. So that's why we want to present both. And this is, this happens obviously because the standard errors are changing, right? Or they're modified to incorporate heteroscedasticity. Okay, so that's what this means. But if you want to make sense of this, you obviously know that the own price effect, if we want to think about what's going on with quantity demanded as the price of eco-labeled apples goes up, the quantity demanded of eco-labeled apples should go down. So the own price effect should be negative, right? There's this inverse relationship between the two. So that's why you see the negative values here. But if you think about what is going on with the price of regular apples, if the price of regular apples goes up, then the quantity demanded, and this is relatively, right? This is when we're thinking about the cross price effect. So if the price of regular apples goes up, the quantity demanded for the eco-labeled apples should rise. So there should be a positive effect. And this is why we're seeing there's a positive effect here, right? These values are positive. So this is something to keep in mind. And obviously, as you know, the family income has a positive effect and things like that. And these variables, you know, are not significant right here. But you know, this variable that says how many people are older than 64, you know, maybe people who are older take better care of their health and they're eating more apples, right? So, or eco-labeled apples, because that's the quantity that we're talking about here. Okay, so this is the idea behind this, and age doesn't play a role, right? So the age above 65, or the number of people who are above 65 plays a role, but age itself doesn't play a role. And that's why sometimes, you know, you want to incorporate variables in a different way. Even though you know the age of the head of the household, you want to incorporate age in different ways. Okay, so that's the idea here.